A very good morning to all of you. I hope everyone has joined. Am I audible? Am I audible, students? Okay. So, I hope your sessional exam was good. Okay, so for today's class, we will be doing your wastewater treatment part. Okay, so this is a fourth module, I guess. This is the fourth module. So we have completed your water treatment part. Okay, so now you have an idea like about all the water treatment plant. Okay, all the treatment processes you know. So, similarly, though you have learned about the wastewater treatment in your fifth semester, so I guess everybody has an idea about this sewage. Okay, so here we will be in this module, fourth and fifth module basically. So in fourth and fifth module we will be dealing with the wastewater treatment. So first of all, we will be like learning about the characteristics. Okay, like we have done for the water, raw water supply. Like we have studied the physical, chemical and biological characteristics of raw water. So similarly, we have to know the physical, chemical and biological characteristics of wastewater is also. Okay, so before that, before starting the module, as a whole, I want to show you like how actually the this wastewater treatment plant actually it works. Okay, so basically there is a short video of 3 minutes. You just watch this video. After that we will be starting with it with our like module. Okay, so first you see what actually how actually your wastewater treatment plant it actually works. Okay, it's just an animated video. We'll just first see, then we will be discussing about today's topic. Okay.
Cities and towns have sewerage systems in place to carry the wastewater from our homes, hotels, factories, and other establishments to a sewerage treatment plant where the wastewater is treated. It is then deemed safe to release into other water sources. The treatment of wastewater goes through different stages. Wastewater is treated to remove the physical, chemical, and biological contaminants present in it through various processes. The pre-treatment process involves the sewage being sent through grids or vertical bars that can remove large solid substances like metal cans, paper, and plastic materials. In primary treatment process, the sewage flows through the grit chamber very slowly, so that the sand, pebbles.
Okay, isn't the video visible to you? It's not playing or what? Okay, it's not playing. Let me just wait. Let me check. It's playing. Okay. For some students, I think they are not able to see the video. Okay, so let me try. Okay, for them, I am just trying to share once again. Okay, I am stopping the sharing, and again I will share. Just wait. Might be because of the network issue also.
Cities and towns have sewerage systems in place to carry the wastewater from our homes, hotels, factories, and other establishments to a sewerage treatment plant where the wastewater is treated. It is then deemed safe to release into other water sources. The treatment of wastewater goes through different stages. Wastewater is treated to remove the physical, chemical, and biological contaminants present in it through various processes. The pre-treatment process involves the sewage being sent through grids or vertical bars that can remove large solid substances like metal cans, paper, and plastic materials. In primary treatment process, the sewage flows through the grit chamber very slowly, so that the sand, pebbles, and soil settle down at the bottom. The sewage flows into the settling tank or sedimentation tank, where the solid wastes like feces are allowed to settle down. Wastes such as soaps, oils, and grease rise to the top of the wastewater. The waste material that settles down at the bottom is called the sludge, and the floatable material is called the scum. Scum is then removed using a skimmer, and sludge is removed with a scraper every few days. The water that is left out is called the clarified water. In the secondary treatment process, biological or organic wastes are removed. It is a biological process. This is done by transferring the clarified water into an aeration tank, where air blowers bubble air, which helps the aerobic bacteria to grow and feed on the organic contaminants such as food waste, feces, and other organisms. The mixture then flows from the aeration tank into the clarifier, where activated sludge settles out by gravity. The activated sludge so produced, along with the sludge produced in the primary process, is transferred to the digester, where it is decomposed by anaerobic bacteria. Biogas is produced in this process. which can be used as fuel or can be used to produce electricity. The activated sludge is then left in the sand drying beds. Some quantity of water in the activated sludge evaporates and the remaining quantity drains through the sand beds. This leaves behind the remaining dried sludge, which can be used for making fertilizers or compost. In the tertiary treatment process, the leftover wastewater is treated with chlorine to remove the phosphorus compounds, nitrogen compounds, and bacteria. It is a chemical process. Chlorine tablets are added to kill the germs. This process is called chlorination. Then this water is let off into the water bodies.
Okay, just wait. Okay, so you have seen the video, right? It's very nicely, it's been shown what are the processes that you will have to know, you have to know, or what are the processes that deals with the wastewater treatment. Okay, so basically what is the use for doing this treatment, because while we studied about this raw water treatment, what we actually did is that we have to use that water for your drinking purpose, or you have to use that water for many other uses. Okay, it means you have to use this water that you have taken from the raw source, that is your lakes, or it might be river. So you have taken it water, and that water is not that it's not that pure, so you have to treat that water, and after that you can use that water for different purposes. After no like now, what is wastewater is that, or what is sewage is that, like now you have used that water. Okay, you have used that raw water for your like different purposes you have used. Now after using that water, now it has finally became a waste. Okay, it will now become a wastewater. So this wastewater, like from your, it can be from your bathroom, it can be it can be feces, or it can be urine, or it can be your kitchen waste. Okay, so different wastes are there. Okay, so like this waste are now, these are carried through the sewers. Okay, sewers are like the pipes which carry the wastewater. Okay, now through these sewers, it is carried to a treatment plant. Okay, because this wastewater, or this sewage, okay, it cannot be disposed of to the river body directly, since it is consisting of different, like it's not pure, or it's very dirty. Okay, so it cannot be, it has organic matters in it, so it cannot be, like you cannot dispose that water directly to the water bodies, because it can be harmful for the aquatic animals and plants that is in the water. Okay, or and also this water, like if you treat it, so you can be using this water for different purposes, like you can use that water for farming. Okay, so different purposes, multi purposes are there of using this treated water. After you treat this water, you can use it for different purposes. Okay, not for drinking, but for like farming and all, you can use it. Okay, and also you can dispose it off to the river bodies, so it will not harm the aquatic plants and animals after. Okay, so like it goes certain it is treatment processes it have to go, and it is different from the process treatment processes from the this raw water treatment process. Okay, it is different from that, since this water, it contains all this oils and like sediments are there, so different like impurities are present in this wastewater. So now we like before you treat the water, you have to know like what are the characteristics actually present in the wastewater. Okay, and so those are also like it's similar to your physical or chemical and biological characteristics of raw water. Okay, so here you have to know that terms are similar, but here the like the thing will be different be under it. Okay, so here for the physical characteristics of sewage, we have the same terminologies. That is, first we have turbidity. Okay, then we have color, then we have odor and temperature. Okay, so these are we have studied in your raw water engineering part also. So turbidity, here actually what is turbidity you see here. So sewage is basically it is turbid. Okay, because you the water you get from like from you wash the look like the dish what these are dishes. When you wash the dishes, okay, then you have the water from the wastewater from your bathrooms. Okay, then in the wastewater again you have some like this vegetables oils. Okay, like while you washes the dishes, then all these things are there. Like there can be matchsticks, there can be greases, there is a soap water. Okay, so all these things are it gives says that the water is highly turbid. Okay, so this turbidity it increases like when the sewage it becomes very strong. Okay, so when the sewage is very strong, so you can say that the turbidity is also very high. So like this turbidity you can measure it through this device known as turbidity rod, or you can say like turbidimeters for your laboratory. In laboratory you can use turbidimeters and turbidity rods. You can in field experiment you can measure it with the turbidity rods. Okay, so this one is similar like we have done for turbidity, and we know we have like three types of turbidimeters: Jackson's, Bailey's, and all these things are there. So this is similar. So next one is your color. So what is like how will you identify whether the sewage is now fresh or it is like stale or septic? So how will you identify? Okay, so there is certain color for the sewage. So this color, obviously you can detect the wastewater by your naked eye. Okay, and if the suppose the sewage color is yellow. Okay, if it is yellow or it is gray or if it is light brown, then you can say that this the sewage is very fresh. Okay, and if the color it becomes black or it becomes dark brown, so you can say that the sewage it is stale and it is septic. That is, you have keep the if the sewage is kept for some like more time. Okay, then what happens, the sewage will become stale, like it will become black in color or it will become dark brown. So it indicates that the sewage is stale and septic. Okay, so other colors are also there, it might be there. So okay, next is your odor. Okay, so what is odor? So sewage, obviously it will have some very like odory smell will be there, but if the sewage is fresh, so it will be odorless. Okay, if the sewage is fresh it will be odorless, but like after you keep the sewage for some 4 to 5 hours, okay, for more time period, if you keep the sewage in that way, so it will become stale finally. And like how it becomes stale, because the when it is fresh there is oxygen in the sewage. Okay, and when it becomes stale, all the oxygen that is like in the present in the sewage, it will finally gets exhausted. Okay, it will go out. So when the sewage when the oxygen gets out of the sewage, so what will happen, the sewage it will give start giving like very odory smell, or you can say offensive odors it will give. Okay, and what is there, there is hydrogen sulfide gas. So like the presence of hydrogen sulfide gas will obviously give you very odory, a very offensive smell or odor, you can say it will give. So that means it is the sewage, it is becoming to decompose. Okay, so that is why it is giving you very offensive odors. So like how will you like measure the this odor? By, like there was a term, if you can remember, that is threshold odor number, that is TON. Basically we write it in capital letter and in abbreviated form. So that is TON, that is your this is a threshold odor number. And with this with the help of this term, the odor of the water or the wastewater you can measure. Okay, so like already this has been explained to you like in your raw water engineering part. Okay, so it is like, like you are taking a very sample of very odory smell of wastewater you are taking. Then you take two beakers. Okay, then you in that odory or a sample of what wastewater, you keep on pouring diluted water. Okay, that is, you can say distilled water, you say. So you keep on giving the pouring the water into that sample. So a moment or a time will come when the odory smell will go out. Okay, it will be exhausted. So in that is the point. Okay, that is the point where you will get your threshold or the number. So this was the formula, this already has been explained to you. Okay, this TON is a Vs plus Vd by Vs. So where what is the Vs? Vs is the, like volume of the sewage, how much of sample you are taking. And Vd is the, like you are going on adding the this distilled water to the sample, and you are making it odorless finally. Okay, so this is a Vd. Okay, so this is whole is your formula for TON. So if suppose numerical comes, I have already showed you there, so you can refer to that video. Okay, again. Okay, so next is your like temperature. So this temperature also, it has effect on the, like in the sewage, in the, you can say in the biological activity of the sewage. So there is a bacteria present in the sewage, so the temperature, it has some effect on the bacteria that are present in the sewage. Okay, so this sewage, it also, it affects the like solubility of gas. Okay, it affects the solubility of gas also. And also this temperature, it will affect the viscosity of the sewage. Okay, so when it affects the viscosity of the sewage, so that will affect the, in the sedimentation process and its treatment, it will affect that. So if like the temperature, so as a whole, it will affect the, all the biological activity of the bacteria that is present in the sewage. So these four are your physical characteristics of sewage. Okay, so next we come to the chemical characteristics of sewage and your testing. So after knowing the physical characteristics, so now you have to know the chemical characteristics also. But before that, I would like to tell you one more thing. Like the average, what is the average temperature of sewage in India? It is taken to be 20 degrees Celsius. Okay, when I share you this PDF, you can read it here. Just wait, let me show you. Okay, so you can read from here. See, the average temperature of sewage in India is 20 degrees Celsius, which is near about the ideal temperature for the biological activities. So you remember this. Okay, what is the average temperature of sewage in India? It is 20 degrees Celsius. So now coming to the chemical characteristics of sewage and your testing. So similarly, you have to know the physical characteristics. You have known that we can see through our naked eyes, but the chemical characteristics we have also to know. So here in the chemical characteristics, we have the first one is your total solids, suspended solids and soluble solids. Okay, then it second one is your pH value, then chloride content, then nitrogen content, presence of fats, greases and oils, sulfides, sulfates and H2S gas, dissolved oxygen, then COD and BOD. Okay, that is chemical oxygen demand and biochemical oxygen demand. Okay, so these nine are the chemical characteristics of your sewage. So first let us discuss one by one. That is, your first one is your total solids, suspended solids, and settleable solids. So let us see what are all this. Okay, so basically, sewage, if I say sewage, so sewage basically it will contain 99.9% of water. Okay, and it contains only about 0.05 to 0.1% of your total solids. You please remember this line, that your sewage, it will consist of 99.9% water and only 0.05 to 0.1% of your total solids. Okay, so sewage is basically a watery mixture. Okay, it's a watery mixture, only a very small percent of, that is 0.1 is very small, so 0.05 to 0.1% of total solids will be present in sewage, and all the 99.9% is your water. Okay, so like this solids, okay, this solids that is present in the sewage, it can be of, like four forms. Okay, there can be, these solids can be of the four forms, that is your suspended solids, dissolved solids, colloidal solids, and settleable solids. So let us now see what are suspended, dissolved, colloidal, and settleable solids are. Okay, from the name itself, I think you can identify what are the suspended solids are. So suspended solids, basically from the name itself, what it is, it, like it, these solids, remain floating. Okay, so suspended solids are those solids which remain floating in the sewage, so they will not settle down, they will just keep on floating. So that are, if you see some sewages like that, so that is known, they refer to that solid is known as your suspended solids. Then what are dissolved solids? From the name you can make an idea, said that these type of, sewages, it will dissolve in the sewage. Okay, dissolved solids are those which remain dissolved in the sewage. Okay, just like you, if you add salt in water, so that will completely dissolve, isn't it? So that is your dissolved solids. Okay, so that kind of solids are known as your dissolved solids, which will completely dissolve in the sewage. Then comes your colloidal solids. So colloidal solids, these are that kind of solids which either remain in solution or in suspension. Okay, so it is like in both part, like it will remain in water or in solution also, or it might be in suspension also. So that kind of solids is known as your colloidal solids. Then comes your last one is your settleable solids. So settleable solids are those solids which, like it settles down. Okay, so if you keep the sewage for like if you don't disturb the sewage for a period of 2 hours or 3 hours like that, so what these settleable solids, they will these are a part of your solid matters obviously, so that will settle down. Okay, if you keep the sewage undisturbed for, for a longer time period. So this is your settleable solids. So next is your, like, the solids. These are again comprises of, two types of solids are there. One is your organic solid, and the second one is your inorganic solid. So what is the organic solids? This organic solids, it is, cover about 45% of the total solids. Okay, and the remaining part, that is your 55%, it is your inorganic solid. Clear? So you see what is inorganic solids. Inorganic solids or inorganic matter, these are from, like say you have salt, like you think like you have sand, gravel. Okay, then your chlorides is there, sulfate is there. So all these things are, from inorganic matters, these are. Okay, so these are your inorganic solids. And your, what are your organic solids? That is comprises of organic matter. That is, you can say in the wastewater, there is, like when you, from your kitchens and kitchen wastewater, when you this wash your rice. Okay, so there will be carbohydrates. Okay, like there will be fats and oils. So all these things are coming from the kitchens or laundries, or you can say from restaurants. So these things are your organic solids. Again, you can say like there are nitrogenous compounds like your proteins, okay, then your this waste from the animals, that is urea, then fatty acids. Those, so all these are your organic solids that is coming from the organic matter, and inorganic solids are those that is coming from the inorganic matter, that is your sand, gravel, debris, all these things, okay. So these are two kinds of, another two kinds of your this solids, total solids. Okay, so now the you now you can measure, actually you can measure these different types of solids that we have discussed just now. So how to measure the amount of total solids, or how to measure the amount of suspended solids, or the settleable solids, how will you measure? So there is a kind of practicals, how to perform these experiments, okay. So let us discuss about these experiments a little bit. So, for finding the total solids, let us mention it as S1, okay, not for not confusing it. So let us mention S1 to be your the total amount of solids that is present in the sewage, okay. So how will you find this the total amount of solids? So you take a sample of total this sewage water, okay, or wastewater, you can say. You take a sample of this wastewater and you just evaporate this sample, okay. You just evaporate the sample, and now after the it has been evaporated, so something will be, some residue will be, it will be left out, okay. So you just weigh the dry residue that is left out after evaporated, after evaporating the sample. So now the mass of this residue, okay, that is the weight of this residue, if you divide it by the volume of the sample that you have taken to evaporate it, so that will give you the total solids, that is in milligram per liter, okay. So how, again I am just repeating, just you have to take the sample of wastewater, and you just you have to measure it, how much of wastewater you have taken, you have to measure it. After that you evaporate it, and after evaporating, when the everything will be evaporated, so some dry residue will be left out. So you just measure the dry residue, you have to weigh the dry residue, okay. Then you have got some value, right? So you have to now just divide this mass of this residue divided by how much of wastewater, how much volume of wastewater you have taken, okay. Just divide it and you will get the total amount of solids that is present in the sewage, that is your S1, okay. So now we are coming to S2, that is your suspended solids. So how will you find the suspended solids? So what are these suspended solids? So in terms of laboratory experiments, how will you say it? Like these are the solids which are retained by a filter of 1 micrometer pores. So basically it's a like when you take the suspended solids, if it is retained in a filter paper, so that is your suspended solids, okay. And how will you find it out actually? So this quantity, that is your suspended solids, it can be determined by passing this sewage sample through a glass filter apparatus, okay. You pass this sample through a glass fiber no filtered apparatus. Will you have seen filters, I think you have seen this cone shaped filters. So you just pass it through a glass fiber filter apparatus, and now you just weigh the dry residues that are left on the filter paper, okay. And the same formula, like you the mass of the residue, you divide it by the volume of the sample, then you will get the suspended solids. So here basically you are using a filter paper, okay. So next is your, like you find out the dissolved solids plus colloidals. Dissolved solids and colloidals, how will you find out? It is just you have to minus the total amount of solids That first one you have got the total amount of solids and the suspended solids that you have got. You just subtract the S1 and S2, then you will get the dissolved solids plus colloidals. Okay, also it is known as your filterable solids. Okay, so next comes your this suspended solids, sorry, the total suspended solids, okay, that you have got. It can be either volatile or it can be either a fixed one. Okay, so how to determine their proportion? Okay, so the dry residue, okay, before filtering, okay, before filtering, so the whatever the dry residue is there, okay, you have got in your, while calculating the suspended solids, so you have to burn the like the residue, okay, you have to burn at 550 degrees Celsius. Okay, there is some electrical muffle furnace is there. Okay, furnace, a kind of furnace, you can say it's a furnace is there. You burn the dry residue, okay, there at 550 degrees Celsius for about how much, for about say you 20 minutes. Okay, you just burn it. So what will happen, there will be some loss of weight in the from the dry residue. Okay, so that will, when there will be some loss of weight in the this from the residue, so that will represent your volatile solids. Okay, and these volatile solids that you have got now, so let it be S4. Okay, S1 was your total amount of solids, S2 was your suspended solids, S3 is your dissolved solids, and now S4 is your volatile suspended solids. Okay, so now after you got your volatile solid is equal to S4, now if you subtract your like suspended solids and the volatile solids, you will get the fixed solids. Okay, so here you see they have minus your S2 minus S4, that is you will get your fixed solids. Okay, so one is your volatile and the other one is your fixed. Okay, so volatile you have got it by burning the dry residue. So after you subtract it from the suspended solids, so you will get the fixed solids. Okay, so next one is your last one is your settleable solids. So how will you find out the settleable solids? So it there is a cone in this figure. You can see this is a cone, and the name of this cone is your Imhoff cone. Okay, Imhoff cone. So here basically you can see it's a cone type of glass. Okay, which is graduated. It has some graduated scale up to 50 ml. Okay, and the cone, it has a capacity of 1 liter. Okay, it has a capacity of 1 liter and the graduations are up to 50 ml. Okay, so the sewage sample, you have to pour it in this Imhoff cone. Okay, and you have to allow it to like you have to keep it for 2 hours. Okay, so what will happen, the quantity of solids, okay, that is present in the sewage, it will settle at the bottom of the cone. Okay, and after that, after it settles down, so you can directly read the how much of solids have been settled out. Okay, so this is your, in this way you can find out the the kind of your settleable solids. Okay, so this is all about you, this is a kind of your like practical experiment only, you can say, how to find this the different type of total solids and this settleable solids and all. So this is kind of experiment. Okay, okay, so now, okay, you can see this table. So this table is basically the you can identify how what is the type of solid. So here you can see is total solids is there, and what the strength is also given. Like if it is like 400, so it will be a weak type of sewage. Okay, and if it is 800, then it is a medium type of sewage. Okay, then 1200 it is a strong sewage. So this like this, the table has been made to identify how what is the type of solid on the basis of strength. Okay, so also you can refer to this table. Okay, so next is comes your pH, chloride contents. Okay, so this part I will be doing it in the next class. Okay, since 5 minutes is left, so the meeting will get over. So from pH we will be doing it in the next class. I hope till now here, from up to here, it is clear to you. Okay, so basic things. Okay, there is nothing to, it's too much, it's not that tough. Okay, so okay, then you give your attendances in the WhatsApp group. Okay, everyone. Okay, thank you. You can leave the meeting now.